t squared minus 5t plus 8 in kilometers per hour. Copy and complete the following table. Well, all you have to do in your calculator is you just go mode, table function. Instead of using t, what do you use? Just use x instead, and you will get all your points as shown. No bother. Start at 0, end at 5, and step at 1, and you get 1 at 0, 8, 1, 4, 2, 2, 3, 2, 4, 4, and 5, 8. So what do I put in these here, guys? 0, 1, 8, 1, 2. Now, see the way the two of them are 2 each? It means the minimum will be at 2.5. Okay, 4, 4, and 5, 8. Okay, now, more than likely it's going to ask me to draw this graph, okay? So I'll just grab all this here. Here, just move all across anyway. There you go. There's the 4 and the 8 and the 3 of them. All right. T0 means 12 o'clock. T1 means 1 o'clock in the afternoon. T2 means 2 o'clock in the afternoon. S0 means 0 kilometers an hour. S1 means 10 kilometers an hour. That makes things trickier, doesn't it? Because the numbers don't mean what they say they mean, do they? All right. Use the completed table. Draw the graph of the function on the horizontal axis and the vertical axis. So we drew a graph here. Is everybody cool with that graph there? Okay, I'll just bring it down. So that's our graph drawn. Everybody happy enough? The minimum point is roughly at about 1.7-ish, somewhere around there for the minimum point. Is that okay? Now, use your graph to estimate the times when the wind speed was 33. Now, what does it say about the graph again? Oh, that's difficult. 33 kilometers an hour would mean what, guys? Divide 33 by 10 and what you get? It has to be where it equals 3.3. Now, where does it equal 3.3? I'm going to draw a line going across from 3.3. So if 3.2, 3.3 is about here. Draw the line going straight across. Now, what do we do next? Bring it down. And roughly what do you get? I think I'm looking at about 1.2, 1.3. And what am I looking at here? 3.7-ish. Would that be okay with you guys? T equals 1.3 and T equals 3.7-ish. Let's reread the question because I don't think it wants that from us. The times. It probably wants it in actual time. Is that correct? So what does it mean by 1 o'clock? This is 1300. That's 1300. That's 1400. That's 1500. That's 1600, and that's 1700. What's 1.3 in hours? So look at this, guys. Let's do it the lazy way. 1.3. Press equals. Yeah. Press this button here. 1 hour and 18 minutes. So what would that mean? 13, 18. Is that all right? What about 3.7? Press equals. Press the change button. That would mean 3:42 in the afternoon, which is what? 15:42. Is that all right? If the answers disagree with in the back of the book, are you allowed to disagree with the back of the book? You are by a small amount. What would be the answers in the back, for instance? 3 what? Is that what it says? No, but if you check the back of the book, it might have a slightly different answer. Something like that, is it? Well, check it and let me know. Now, the speed of the wind when it's 16:45. Do you get what I'm saying? 16:45. Now look at this. 16:45. That's 16 3/4. Would you agree with that? Which is 4 3/4. So where is 3/4 of the way up here? Halfway, between halfway. So 3/4 is around here, isn't it? That's 4 3/4. Yes, sir. And what? Yeah, I'm pretty close, haven't I? So it says 13:15 and 15:45, which means I'm very close to getting the same answer, which is allowed. Now, what happens when I come up here? This is roughly meant to be 4 and 3/4. So you go up and you go across, and what do I get? Let's see how much I disagree this time. I think I'm getting around 6.6, but 6.6 is not correct. What do I have to multiply 6.6 by? I have to multiply it with 10, don't I? So I'm about to get 66 kilometers an hour. What's the answer in the back of the book? 66 kilometers an hour for me, which is what for you guys? On the same axis and scales, graph the function f of x equals 15 plus 2x minus x squared and g of x equals 15 minus 2x in the domain 0 less than or equal to x less than or equal to 5. The ski jumper shows the path of a ski jumper as she leaves the ramp. The path of the jumper is given by 15 plus 2x minus x squared, no bother. The landing hill is given by 15 minus 2x. Each unit on the x-axis represents 1 second. All right, here's what we're going to do really quickly. Throw this into your calculator. Mode table 15 plus 2x minus x squared. Start at, anybody? How do I know I'm starting at 0? Time starts at 0. I don't know where to end, do I? I'm just going to put in 20 for the crack, and we'll see what happens. Yeah, but let's say 0, 15 for the first one. Is that all right? Does everybody have these points on them? 0, 15, 1, 16, 2, 15, 3, 12, 4, 7, and finally 5, 0. So this is 5, 0. What's next? What's this? 0, 15. The peak is roughly 1, 16. Here is roughly 2, 15. What's the next one? 3 what? 3, 12 is somewhere around here, I'd say. And the one after that? 4, 7. I don't know if that's the point of intersection or not. I'm going to check that now. What's the next thing I can check? Use your calculator and lob in. 15 minus. Use 15 minus 2x this time. 0 to 20 again. Step of 1. Starts off at 0. 15. 4, 7. So we have the 2 points of intersection now, don't we? 0, 15 and 4, 7. So essentially your skier or snowboarder comes down the ramp, leaps off the ground. See here? That's actually the ground. He's in the air and then bam, back onto the slope. Does that make sense? Yes, sir. Oh, I shouldn't have. I should have just went 0, 5. I just had extra points for no reason. You're right. Now, each unit on the x-axis represents 10 meters. So what is actually your largest height then? 116 is actually 1 and 160. Great. So what's the maximum height of the ski jumper? Okay. The time it takes for the ski jumper to land on the hill? 4. Land back on the hill is 4 seconds. Wait, the time it takes the ski jumper to land on the hill. The landing, she leaves the ramp and the landing hill. So is everybody happy with 4 seconds when she hits it again? 5 seconds is the ground and the line is the landing hill. So I think this counts as the landing hill, this part here. This is actually, the yellow line represents the hill / landing ramp. So he hits it at 4. Now, the time it takes for him to land back down again is 4 seconds into his jump. If you go back to the beginning, all right, he comes here, at 0 seconds he lifts into the air. and he's off the ground because he's not touching the yellow part, is he? And then he only hits the ramp. Yeah, exactly. But he doesn't land at 215, okay? Now, the height when the jumper lands on the hill. He's 7 meters above ground, isn't he? Because it's 4, 7. All right, any problems with that one? 7 meters above, we're all good? All right. What? Oh, 70. Thank you, because each one is worth 10, so that's 70 meters above the ground. We all good? Awesome. Next one we're doing. Is that it? I did 11. Did I not do A? I didn't do A. All right. So, can somebody call out this equation to me in a second's time? 30 plus 25t minus 5t squared, okay? Going to do this again. All right, go for it, call it out to me. 30, yeah, plus 25t minus 5t squared. Is it a time question? It is a time question, is it? Is it 0 to 6? The domain 0 to 6, is it? But it's 0 to 6, is it? Oh God, look at this. It's huge, isn't it? And I'm just going to stretch this out a bit. Make it a bit nicer first. All right, you should end up with a graph like this, and it's quite difficult. So what we're going to look at next is, here's your graph. Okay, so can everybody put that equation into your calculator and just call me up the points that you got in a second, because I'm going to write them onto the graph, okay? So what you do, guys, is you put this into your calculator. So instead of using E, you're going to use 30 plus 25 x minus 5 times x squared. This is question A. Then you go from 0 to 6, is it? 0 to 6, step of 1, and you get all these points here. Is that okay? Now, so let's have a look-see here. Okay, so your first point is what? 0, 30, which is here, yeah. Next one. 150, yeah. Now, just to 260 and 360. That means the maximum point happened in between. So what we will do here is we go back here, and then we press equal. We restart again. Except this time I do a step of 0.5, and I look at 2.5, and 2.5 is 61.25. So that's actually 61.25 for the maximum size, right? We just keep the mass up, lads. Okay. Now, next one, 450, and finally, and then after that, you're allowed to stop once you're at 0, aren't you? All right. Has everybody drawn a graph like that, somewhat like that? Okay. Now, what's the maximum height reached by the ball? Okay. The number of seconds for the ball to reach a height of 60 meters for the first time? Huh? 2 seconds? Yeah. Number of seconds taken for the ball to reach the height of 60 meters again? 3 seconds. Again. 3 seconds or 1 second after the first time. You just present your answer properly, okay? So explain what you mean. What's the height of the ball after 4.5 seconds? Where do I need to go to? Halfway between 4 and 5. And I go up. So halfway between 4 and 5? Around 41-ish, is it? I'd say we have the answer in our calculator, do we? Look, you can actually cheat this. Ah, brilliant, 41.25. Super calculator to the rescue again. So that should be 41.25 meters. Is that okay? After how many seconds will the ball reach the height from where it started? It started at 30, 5 seconds later, isn't it? After how many seconds will the ball reach the base of the building? All right. It's not so bad, is it? All right. Let's go a bit deeper. So the furthest we got was 11, was it? Can you guys try 14, please? The first things, guys, is you get the points from 0 to 5 for the first graph, the points from 0, 1 to 6 for the next graph, and you draw them. So we can see here that f of the first missile is the red line here. That's the first graph drawn, and then the second graph drawn is the blue line. Everybody cool with that? So that's the first missile with the second missile, okay? Now, it gives you specifics about the what everything means. X equals 0 means 0, 500, and x equal 1 means 510. So this will be 5, that's 510, that's 520, that's 530, that's 540, that's 550, and finally that'll be 6 o'clock or 6 a.m. Everybody cool with that? If you can't see the board, just pull down the blind or two. Okay. Now, okay. Incoming missile was launched. Which one's the incoming missile? The incoming missile is the one that was launched at 5 o'clock. How high up is it to begin with? 2. What does 2 represent? 2 represents 2 kilometers. So did everybody get a height of 2 kilometers above the ground? Is that right with you guys? 2 kilometers. The maximum height reached by the incoming missile is around here, which is 8 point what? 8.2-ish, or 8.25, which would be 8.25 kilometers for the maximum height. Sorry, 8.25 kilometers. What height did the two missiles hit each other at? Here it is. So what's the height? 6 kilometers in the air. So 6 kilometers in the air for the two missiles hitting each other. What time did they hit each other at? 4 is not the answer though. 5:40. Is that okay? 5:40. 5:40. All right.